The Java Enterprise Edition, or Java EE platform, emerged to address the growing complexities of building robust, scalable enterprise applications. A key challenge in this domain was managing persistent data, information that needs to survive beyond the lifecycle of a single application execution. To tackle this, Java EE introduced Entity Beans, a technology designed to simplify the interaction between Java objects and relational databases. Entity Beans aim to provide an object-oriented view of data stored in relational databases. Developers could define entities as Java classes, mapping them to database tables. This abstraction promised to ease development by allowing developers to work with data in a more natural, object-oriented manner. The idea was to encapsulate database interactions within the entity beans themselves, shielding developers from the intricacies of SQL and database connections. The introduction of Entity Beans marked a significant step towards bridging the gap between object-oriented programming and relational databases within the Java EE ecosystem. They promised to streamline data persistence, a cornerstone of enterprise applications. The concept was revolutionary for its time, aiming to simplify a traditionally complex aspect of application development. Entity Beans arrived with a wave of optimism. They promised to simplify the development of data-centric enterprise applications, freeing developers from the tedium of low-level database interactions. The initial implementations of Entity Beans, while not without their challenges, offered tangible benefits. One of the key features of Entity Beans was their ability to handle persistence transparently. Developers could focus on defining the business logic of their entities, leaving the details of database interactions to the container. This separation of concerns allowed for cleaner code and a more object-oriented approach to data management. Furthermore, Entity Beans introduced the concept of container-managed relationships between entities. This meant that developers could model complex relationships between different data objects, reflecting the real-world relationships within their applications. The container would then manage the persistence of these relationships, ensuring data integrity and consistency. This feature, though powerful, would later contribute to the complexity associated with Entity Beans. While Entity Beans held great promise, their initial implementations proved to be more complex than anticipated. Developers encountered numerous challenges when working with this technology. The learning curve was steep, and the development process often became cumbersome. One major criticism was the heavy reliance on XML configuration. Developers had to define complex XML descriptors to map Entity Beans to database tables, specify relationships, and configure various aspects of their behavior. This XML-heavy approach led to verbose and often difficult-to-maintain code, detracting from the initial goal of simplification. Another challenge was the performance overhead associated with Entity Beans. Early implementations were often resource-intensive, leading to performance bottlenecks in applications. The container-managed persistence and relationship management, while powerful, came with a significant performance cost. Developers found themselves grappling with tuning and optimization issues, further adding to the complexity. As developers grappled with the complexities of Entity Beans, a new contender emerged in the Java persistence landscape: Hibernate. Hibernate, an open-source project, offered a more lightweight and intuitive approach to object-relational mapping, or ORM. It focused on simplifying the mapping between Java objects and database tables, using annotations and a more streamlined configuration process. Hibernate's reliance on annotations reduced the need for verbose XML descriptors, making code cleaner and easier to understand. The framework provided a more direct and flexible way to map entities, allowing developers to express relationships and data constraints in a more natural manner. Moreover, Hibernate offered improved performance compared to early Entity Bean implementations. Its architecture was designed for efficiency, and developers found that Hibernate-based applications often outperformed those built with Entity Beans. This performance advantage, coupled with the ease of use, quickly made Hibernate a popular choice among Java developers. The success of Hibernate underscored the need for a standardized and simplified approach to persistence in Java EE. This led to the development of the Java Persistence API, or JPA, a specification aimed at unifying the various persistence frameworks under a common standard. JPA borrowed heavily from Hibernate's concepts, incorporating annotations, a streamlined configuration process, and a more developer-friendly API. The introduction of JPA marked a turning point in Java EE persistence. It provided a vendor-neutral specification, allowing developers to write persistence code that could work seamlessly with different JPA implementations. This portability was a significant advantage, as it reduced vendor lock-in and provided more flexibility in choosing the best persistence solution for a given project. JPA's standardization efforts simplified the persistence landscape, offering developers a consistent and robust API for managing data in their Java EE applications. This standardization proved instrumental in the eventual decline of Entity Beans, paving the way for a more streamlined and developer-friendly approach to persistence. To understand the shift in Java EE persistence, it's crucial to compare the three key players: Entity Beans, Hibernate, and JPA. Each technology offered a different approach to managing data, with varying levels of complexity and flexibility. Entity Beans, despite their initial promise, became synonymous with complexity. Their heavy reliance on XML configuration, coupled with performance challenges, made them a less desirable option for developers. Hibernate, on the other hand, gained popularity due to its simplicity, efficiency, and annotation-based approach. JPA, building upon Hibernate's success, provided a standardized and vendor-neutral API for persistence. It combined the best aspects of Hibernate with the portability and standardization offered by a Java EE specification. This standardization proved crucial in shifting the landscape towards a more unified and developer-friendly approach to persistence. The evolution of Java EE persistence witnessed a gradual shift away from the complexity of Entity Beans towards the simplicity and efficiency of Hibernate and JPA. This transition was driven by the need for more manageable, performant, and developer-friendly solutions. As Hibernate gained traction, its influence on the Java persistence landscape became evident. The concepts pioneered by Hibernate, such as annotations and a more streamlined configuration process, found their way into the JPA specification. This adoption solidified the shift towards a simpler and more standardized approach to persistence. The transition wasn't immediate. Legacy applications continued to rely on Entity Beans, and developers familiar with the technology were hesitant to switch. However, the benefits of Hibernate and JPA, coupled with the growing community support and industry adoption, eventually led to a widespread shift in preference. At the heart of any persistence technology lie two fundamental aspects: persistence, the ability to store and retrieve data, and transaction management, ensuring data integrity and consistency. Entity Beans, Hibernate, and JPA each address these aspects in their own way. Entity Beans, through container-managed persistence, provided a level of abstraction for handling data interactions. The container took care of persisting and retrieving entity data, managing relationships, and ensuring data integrity. However, this abstraction came at the cost of complexity and performance overhead. Hibernate and JPA, while offering container-managed options, also provided more direct control over persistence and transactions. Developers could choose to manage transactions programmatically, giving them finer-grained control over data interactions. This flexibility, combined with a more streamlined approach to persistence, made Hibernate and JPA more appealing to developers seeking greater control over data management. In the current landscape of Java EE persistence, JPA reigns supreme. It has become the de facto standard for managing data in enterprise applications. The transition away from Entity Beans is largely complete, with JPA offering a more mature, flexible, and developer-friendly alternative. JPA's success can be attributed to its standardization efforts, making it compatible with various persistence providers. This vendor neutrality allows developers to choose the best JPA implementation for their specific needs without being locked into a particular vendor's ecosystem. The widespread adoption of JPA has led to a thriving ecosystem of tools, libraries, and frameworks built around the specification. This rich ecosystem further simplifies development, providing developers with a wealth of resources to streamline their persistence efforts. JPA's dominance is a testament to its success in simplifying and standardizing data management in Java EE applications. The evolution of Entity Beans to JPA highlights a crucial lesson in software development: the importance of balancing power with simplicity. While Entity Beans aim to provide a comprehensive solution, their complexity hindered adoption and ultimately led to their decline. Hibernate and JPA succeeded by focusing on a more streamlined and developer-friendly approach, prioritizing ease of use and efficiency. JPA's dominance in the Java EE persistence landscape demonstrates the value of standardization. By providing a vendor-neutral specification, JPA fosters competition and innovation among persistence providers, ultimately benefiting developers with a wider array of choices and a more robust ecosystem. The future of persistence in Java EE is likely to involve further refinements to JPA, incorporating new features and optimizations to address emerging challenges in data management. The lessons learned from the Entity Bean era serve as a valuable reminder that simplicity, efficiency, and standardization are crucial factors in driving adoption and ensuring the long-term success of any technology.